are you doing today?
Good. How are you?
Good. So what do we got going on today?
We're doing statistics right now,
Okay.
and I don't get how to, like, do and, like, if there's, like, a dice and a coin flip,
Uh-huh.
I don't get how to find the probability of and,
Okay.
like, a 1 and a heads or whatever.
And is both things have to occur. Okay? So
Yeah.
let's say I said, what are the odds of rolling an even number on one dice? What are they?
1/2.
And what are the odds of drawing a black card from a deck of cards?
1/2.
So I would multiply. So if I had a problem that said, what are the odds of throwing an even number on a dice and a black card from a 52 deck of cards when you draw? Well, those odds would be 1/2 times 1/2 because they both have to occur.
All right.
Let's take another situation. Say this ain't the greatest situation, but let's say there is a 40% probability it's going to rain today. And independently, there is a 30% probability it's going to rain tomorrow. What's the probability it'll rain both days?
Would it be, what, 4 times? So, 0.7? Or, what? Oh, no.
Because they both have to happen. Okay? If they both have to happen, then you multiply the probabilities. Now, the reason this is a bad problem to give a probability student, because point in fact, whatever the odds are of it raining today are not independent from the odds of it raining tomorrow. If it does in fact rain today, it's more likely to rain tomorrow. So this is just for illustration purposes. This particular problem is not real life. Unfortunately, a lot of probability people use it. Now, let's say, what is the probability that I will hit an even number on a die or an odd number? What's the probability of an even number?
Or an odd number, so wouldn't it be 1 or 6 over 6?
In other words, when it's or, you add. When it's and, you multiply. I don't know if that's a standard rule, but I think you could probably use that rule. In other words, if I said the probability it was going to rain today was 1/2. Hold on, let me think about that for a second. No, that's not a good example to give you. Let's talk about rain once again. The weatherman says the probability it's going to rain is 1/2 today. Probability it's going to rain tomorrow is 50%. What's the probability that it'll rain on either day? In other words, what's the probability it's going to rain either today or tomorrow?
It would
Not
rain,
one.
so
Not one.
100%?
No, because it's
Like,
not
no.
going to rain 100% of the time on one of those 2 days. The way to figure this out is if the probability it's going to rain is 1/2, then the probability that it's going to not rain is 1/2. Same thing over here, not rain is 1/2. So the probability that it will not rain both days is 1/4. Multiply them. In other words, you would have to have it not rain on this day and not rain on tomorrow. So the probability that it won't rain on both days is 1/4. Now, what's the probability that it'll rain on at least one day?
Three-fourths.
Exactly. In other words, it's 1 minus the probability that it would not rain on both days. So the probability that it will rain on either day is 3/4. And this is kind of how you have to do it, is you have to figure out the probability that it won't rain twice. Do you have some specific problems we can look at? Because probability problems can range from low end of the spectrum to really, really hard. So it's best if you give me some problems, because that'll give me an idea of the level of difficulty they're giving you.
I don't have any that are or and. They're just, it's literally trying to find the percentage. And that's not what I need. I was trying to figure out, because my teacher isn't going to be there for 2 weeks, and we have a sub that doesn't know what he's talking about.
Well, that's pretty common on probability and statistics. It's a difficult subject. It's not something I tutor, course alone. If I had a student, a new one, come to me and said, I'm taking a probability and statistics class, can you tutor it? I would say, no, I can't. I do tutor students on probability and statistics, but only the kind they get in an algebra class or a pre-calc class. It can get brutally difficult. Let me pull out my... I left my algebra book in the car. Hold on a second. I'm going to pull out my pre-calc book and see if I can find some problems. It's awful hard to discuss math without problems.
Yeah.
It's just you can't really do it conceptually and do an adequate job of it. Okay, so you're saying the primary thing they've talked about is the probability of an event happening, which is the number of outcomes that are likely versus the total number of possible outcomes. Let's talk about a deck of cards. You familiar with a deck of cards? There's 13 cards from each suit of 4 suits, so there's 52 cards in the deck. It's the probability of getting a face card or a 10. In other words, one of those 4 cards. You can leave it as that. You don't need to simplify it.
Okay.
16 over 52. Now, what's the probability of getting a face card or a spade?
Face card or spade. Would it be 25, 50 seconds?
No, you're double counting, and that's where you need to... In other words, how many face cards are in the deck?
Oh, there's 12.
Okay, and there's 13 spades, but 3 of those spades we already counted. So there's only 10 additional spades.
Okay.
So it's 22 over 52. What's the odds of getting, well, this is pretty easy, but a face card and a spade?
So 3 over 52.
Yeah, there's only 3 of those. The jack of spades, queen of spades, or king of spades. Let's see what else we got here in my book. Conditional probability. Have you gotten to conditional probability yet?
What is that? Because we haven't really gotten names of things.
Okay. Well, I might be looking in the wrong book then. Because I'm looking in my pre-calc book, not in my algebra book. It'd be better if I had my algebra book. The pre-calc book gets hard very fast. Yeah. And I certainly don't want to go at it faster than you are learning it. It's hard enough as it is. So I only have one very small chapter too. Hold on, maybe this will help. It's probability of tossing 2 heads in a row on a fair coin in 2 tosses.
Wouldn't it be 1/8?
No? What's the probability of tossing a head on the first toss?
1/2.
What's the probability of doing it on the second toss?
1/2.
This is an and, because you have to do it on both tosses, so you have to be successful twice, 1/4.
Okay.
Okay. It's probability of rolling a total of 4 on a single roll of 2 fair dice. First of all, with 2 dice, it's worth knowing how many different ways they can be rolled. In other words, we have to figure that out first. Well, or second. How do you get a 4 on 2 die?
1 and 3 or 2 and 2?
And that's it. Okay. So, how many ways are there to roll that? Oops, excuse me.
Yeah. 2.
Right. It can be 1 and 3, or it can be 3 and 1. So there's 2 ways. How many ways are there to roll that?
1.
Okay. That's good. And there's total of how many ways to roll 2 dice?
Would it be 36?
Yeah. There's 6 numbers that can come up on the one dice. There's 6 numbers that can come up on the other die. That's 36. So the way of rolling a 4 would be 3 over 36. Only 1/12 of the time will you roll a 4. As opposed to a 7, you can roll a 7 7/36. Not because it's 7, but you can get a 7 with a 1 and a 6, a 2 and a 5, a 3 and a 4. Which means there are 1 and a 6, a 2 and a 5, a 3 and a 4. There's 6 ways to roll a 7, not 7. So, are you familiar with the game Craps?
Yeah.
Do you actually know how to play it?
No.
Okay. Because it's pretty complicated. But essentially, the 7 is the magic number, and it's the one that comes up the most often. And if you roll a 7 or an 11 on your first roll, you win automatically. But if you roll any other number, let's say you roll a 4, now you roll again until you roll a 7 or a 4, and if you roll a 7, you lose. So 7 is the powerful number because it's the one that has the most ways that it can be rolled. It has 6 total ways you can roll a 7, whereas there's only 3 ways to roll a 4.
Okay.
It's the odds of guessing all 6 numbers in a state lottery that requires you to pick 6 numbers from 1 to 46.
So when you do 1 over 46 times 6 times,
That's it. Exactly right. There's 1/46 chance of getting the first number right, and there's 1/46 chance of getting each number right, and you have to get all 6 of them, so it's multiplication. Hold on a second. Yeah, okay. I was just verifying something I had said. Find the probability of rolling a total divisible by 3 on a single roll of 2 fair dice.
It's the what?
You roll a pair of dice, and you want the probability of rolling a number that's divisible by 3. So what are the available winning outcomes?
3, 6, 9, 12.
That's it. Well, we know there's 36 ways to roll a pair of dice. How many ways to roll a 3?
2.
You go through each one, figure out how many ways to roll a 6, a 9, a 12. There's only one way to roll a 12. And you add them all up. In other words, this is 2/36. This is 5/36. A 9 is 4/36. And this is 1/36. So if you want to know the chances of rolling a number, one of these 4 numbers, add up these 4 probabilities, and you get 12/36. So there's 12/36 chance, 1/3 chance of rolling a number that's divisible by 3. And probabilities have to add up to 1. That's another important concept in dice. If I laid out all of the possible outcomes of a die, of a pair of dice rather, 1 through 12, and then laid out the probabilities of each one of them happening, they would have to add to 1. there's only one way you can roll. No, you can't roll a 1.
No, you can't roll a 1.
But you can roll a 2 in only 1 out of 36 ways. And you can roll a 12 in only 1 out of 36 ways. So when you add all the others, we figured out there were 2 ways to roll a 3. When I add each one of these up, I will get exactly 36 over 36. In other words, obviously 100% of the time we're going to roll a number between 2 and 12.
Okay.
Yeah, these are getting kind of hard. Hold on. Yeah. Have you done Venn diagrams with probability at all?
Yeah, we started doing it.
Let's talk about one of these. In a large high school, 54% of the students are girls and 62% of students play sports. Half of the girls at the school play sports. What percentage of the students who play sports are boys? Well, we'll do a standard Venn diagram as with a rectangle and 2 circles. And usually you have 4 categories. Okay? There's the girls. There's the people who play sports. There's this area that are both girls and play sports. That's the 3rd category. And then there's the area outside of here who are students at the school that are neither girls and don't play sports. So this is a typical Venn diagram problem. Now, if hold on a second. If 54% of the students in the school, let's arbitrarily make it 100 students, just because it's actually a little easier to understand if we do that. It's not necessary to do that, but we're going to do that. And 54% of the students are girls and half the girls play sports. Well, that means the total area of the girls has to have 54 girls in it, right? We know that half of those play sports. That means this area here, the other half has to have 27 in it. We also know that 62% of students play sports. Well, that means the whole sports thing has to total 62, so there would have to be 35 people who play sports who aren't girls.
All right.
And if you add up those numbers, you get 89, which leaves 11 outside. So what percentage of the students who play sports are boys is 35%. If a student is chosen at random, what is the probability it is a boy who does not play sports?
11%.
Right. And like I said, it's easier to view this if I use 100 students. But if I don't tell you how many students, the problem in my book doesn't have the total number of students. So each of these, instead of adding to 100, would add to the number 1. So there's really 27% are girls who don't play sports, 27% are girls who play sports, 35% are non-girls who play sports, and 11% are boys who don't play sports. So you don't need the total number of students. You just need these percentages to always add up to 1. That's the thing with probability. All possible outcomes have to add up to 1. We roll a fair die 4 times. What's the probability that we'll roll 3 all 4 times? 1 die only.
Would be 1/128.
What's the probability we'd roll a 3 on the first roll?
1/6.
Second roll?
1/6.
So there's the probability of doing it 4 times in a row. 1/6 to the 4th. What's the probability of rolling no 3s?
In those 4 rolls?
Obviously,
What?
1, no, sorry. It's not 1 minus that. What's the probability in the first roll?
5/6.
Second?
5/6.
So the answer is 5 to the 4th divided by 6 to the 4th. Whatever that number is, or 5/6 to the 4th power. Now here's where they get a little bit harder. And this is where this is probably beyond you. I won't go into this problem, we don't have time. But the third question was, what's the probability that we would roll exactly 2 3s?
Wouldn't you have to Wouldn't you have to?
Gets harder. Yeah, this is very hard.
Wouldn't you have to take the 5/6 to the 4th and then subtract 1/6 to the 4th twice?
Well, this is, no, not really. Let me briefly, I have a 4:30 session, so I can't even go into the explanation. But the explanation would be, well, you could roll the 2 3s there and 2 non-3s there, right? So that's 1/6 times 1/6 times 5/6 times 5/6. Or you could roll a 3 there and a 3 there and non-3s there. Or you could roll a 3 there. You have to count out all of the different ways. This is just 3 different ways that you could roll exactly 2 3s. There's 3 others. In other words, there's actually 6 ways that you could put 2 3s and 2 non-3s together if you count them each out. So since there's 6 ways, it's this times 6. The product of this, in other words, the way of rolling exactly, the first 2 rolls were 3s and the next 2 are non-3s would be this And since there's 6 exact ways of doing that, 4 taken 2 at a time is 6. Then you got to multiply it by 6. All right. Sorry I didn't have my algebra book. I probably could have come up with some better problems for you. So
It's fine.
we will live with that for now, and I will talk to you next Tuesday.
All right.
Bye, Mitch. Bye-bye.
Bye.